It seems to be up. All right, so your grades are entered, and I gave feedback in some cases on Canvas under the submission comments. So let me make a few comments in general about the exam, and then we'll go through and look at specific questions. So, general comments. So if you feel like you did not do as well as you had hoped to do, or if your grade was low, so first of all, I don't want you to panic too much, okay? I want you to panic a little bit, enough to motivate some course correction, okay? But I don't want you to think, you know, I got a negative grade on my midterm, there's no way I can pass the course now, okay? It's absolutely not true. Everybody here can pass this course. Everybody here can learn this material well enough and move on to 222 and have a great time in that course as well. So nothing is set in stone at this point, okay? This is one assessment. It's sort of a halfway through, but it's an opportunity for potential course correction. So here's something that I've seen in a few cases, actually in a number of cases, where people seem to be doing well on the programming assignments and on the ODPs, and then they had what seemed like a great deal of trouble with the programming part on the midterm. And if that feels like it describes your situation, here's a few possible things that are going on. First of all, you know, a midterm exam programming question is not like writing an ODP or a 2-week programming assignment. It's timed. There's pressure on you. You're writing longhand, and you don't get the benefit of trial and error. You can't put in something that you think looks reasonable and try it and see what happens, right? And you don't have access to any resources other than your note pages. So you can't look at old code if you didn't happen to bring it with you, and so on and so forth. These are arguably artificial circumstances in which to test, and I understand that and I acknowledge that. But there are things you can do to help you be more successful with something like, you know, you've got 10 minutes to write this program on paper and you got to get it right the first try, right? And if you get yourself to where you're more successful in doing those kinds of things, guess what? You're going to be a more successful programmer in general. Because even though you can compile code and the compiler will check for syntax errors, if you write code with fewer syntax errors to begin with, you're going to write code more quickly. And you're going to spend less time dealing with the minutia of syntax and more time dealing with algorithms, which is what people are going to pay you to do, right? To come up with algorithms and implement them. And if I gave you comments and said, come and talk to me, right, this is part of what I want to talk to you about. Seeing if there's ways that you can change how you go about doing the programming assignments or the one-day programs. Trying to have note sheets that to you, you know, have the helpful information that you need to not make syntax errors, right? If you can't remember argc, argv, put it down on your note sheet and refer to it when you write your code. And try to write your code to get it as close to compiling the first time as possible, right? Take it as just kind of a challenge, as opposed to just randomly writing stuff and not even trying to remember it, because you know if it's wrong, the compiler will give you an error, and you can do something different. So that's a few things. So I spent some time thinking this weekend, if I could name one thing that I think helped me become a better programmer, what would it be? And here's what I came up with. When you encounter a bug, you write your program, it compiles, you run it, and it doesn't do what it's supposed to do. You encounter a bug, do not get rid of that bug. Do not change it, do not delete it, do not fix it until you completely understand it. And I think this may be the most important thing you can do when you're programming. Understand your bugs. Okay? Because there's really no such thing as a bug. if I say access memory location 0 and I run my program and it prints out seg fault, that's not really a bug. That's what the program is supposed to do, right? So anytime you have a program, even if it's not doing what you wanted it to do, it's doing something perfectly in response to the code that you wrote. And what I would say you need to do is understand that code that you wrote and how it led to the behavior that you see in the program. That's more important than getting the program to work, right? Because the programs we do in here, they're just exercises, they're assessment tools. They're not going into, you know, life support systems or nuclear reactor control panels. They're just exercises. And so take what the code is as you wrote it and try to understand exactly why it did what it did. If you can do that, right, you will understand that bug perfectly, and you probably won't, if that was a mistake, you probably won't repeat that mistake again, right? And once you understand the nature of that bug, you can say, oh, okay, I told it to set this variable equal to 1, and then if it was equal to 1, to return. Okay, what did I want it to do? I wanted it to test to see if the variable was equal to 1. And now you can go ahead and you can modify the code and say, oh, I should have written it like that instead of this. So make that change, compile without syntax errors, run it. If that works, okay, now it works, but it's not just because, you know, you stumbled across the magic solution. It's because you understand why the last thing didn't work. And you probably understand why this one does work. And the next time you have to do something like this, you're going to go to the one that worked, right? And you're a better programmer now. Yeah?
So you're saying that we should save those bugs in like a separate folder and
I'm saying that
just make sure
hopefully you're starting early enough that you have some time. And when you get a bug, right, start trying to understand what it does. So how do you do that? If it's a relatively short piece of code, which hopefully it is, start pretending you're the computer. Write down the variable values as they get assigned. Put question marks if it doesn't have a value. Go through statement by statement and see what it does. Update your variables. If it says if and that condition is true, do the body of the if statement. If not, skip the body, and so on, until you get to the point where what you've written down on paper matches exactly what the computer actually did when you ran your code, right? But chances are, before you actually get to that point, you'll be at a point where it's like, oh, wait a minute, why did this just change value? That's not what I wanted to have happen. You look and you'll say, oh, because I said equal instead of double equal. Or I said greater than this and greater than that instead of or whatever the mistake might be. So ideally, you know, find it as you're right there, because it's also fresh in your mind why I wrote this code, what was I thinking? Right, and that's when you want to say, oh, but that actually means this, not that. So I would try to do it at that point before you move on. Because it's very easy to say, okay, this didn't work, I wasn't sure if that would work or not, let me try this. Let me try an or instead of an and, because I'm never sure which is which. So you change the or to an and suddenly it works. Okay, that's great, but you're still not going to be sure about should it have been an and or an or. So if you try it and you put an and in your condition and it doesn't work, go through and figure out what the and does, right? And now you're going to know, oh, it's doing both of these things. That's not what I wanted. I wanted either one, as an example. All right, does that make some sense? All right, so let's go through these questions and let me talk about how you could do these, and let me also talk about some of the things that I saw. So write a C program which asks the user for an integer. If the user enters exactly an integer, it should print the square of that integer, otherwise print error. All right, so first of all, it's a C program, not a bash script. Secondly, you're supposed to print out the square of the integer, not the square root. Okay, we usually don't do square roots of integers anyway. But I wanted the square. So that's an easy, you know, that's not a fundamental flaw in your programming ability. It's just jumping to a square root. Ask the user for an integer. Okay, that's a prompt. And we're often going to see this sequence, prompt, which says, hey, user, yeah, you, give me an integer, okay, followed by some sort of input operation. Because when we want to read stuff in C, really all we can do is just read in a bunch of characters. That's what fgets does for us. But we can't print out the square of a bunch of characters, so we need to parse that input or convert it. In this case, convert a bunch of characters into an integer, and then we can square it and print it out. Or if something goes wrong, we can't convert it to an integer, we can say error. All right, so ask the user for inputs. You got to have some kind of prompt, okay? So give me an integer. That's a prompt. If we want to read a bunch of characters from the user and save them somewhere, that's fgets. Okay, doesn't do any interpretation of their input. It's purely just let them type a bunch of stuff, whatever they type, let's throw it into a memory array, an array of characters, a string, so that we can do stuff with it. And fgets is generally the same thing every single time. The name of a character array, the length of the character array, and then standard in. So that's the prompt. That's the input. And then we need to parse it. We need to change a bunch of characters into an integer. That's Sscanf. So Sscanf takes the same set of arguments. The string, the bunch of characters that you want to convert, comes first. The format that you want to use to convert it. And if we were just looking for an integer and we didn't care about what else was on there, we could just say %d. But if we want them to input exactly an integer, that's where we do this %d, %s thing, right? So I want to know if there's anything after that integer, and then the name of the integer we're going to read, and a place for some extra stuff. Yeah?
Could it also be %c?
It cannot be %c because %c will actually match a new line. So even if they just type an integer, it'll say there were two things on there. All right. So we need to have a number, thing to fgets into, and some extra stuff here. And this extra in Sscanf has got to be just extra. It can't be ampersand extra. It can't be extra bracket 0. It can't be extra bracket bracket. It's just the name of the variable, which is the address of the first character. This %s is looking for an address where it can start storing characters. So for an array, we don't have an ampersand. For an integer, we do. If we had a character, we would have an ampersand. Same with a float or a double. So there's a few possibilities. They might not have typed an integer. They might have typed an integer followed by other stuff, or they might have typed exactly an integer and just hit enter. Right? The only reasonable way to know that is to look at the return value from Sscanf. If we initialize extra to be an empty string, we could see if it's still an empty string, and that would probably get us there. But just look at the return value from Sscanf.
I think I forgot how the return value of Sscanf.
Okay, so okay, so if it returns 2, then it found an int and a string.
Right.
If it returns 1, it found exactly an int. If it returns 0, it did not begin with an int. If it returns -1, it was an empty string.
Wouldn't it return with an empty string? What if it found a string and no int?
If it found a string without an int, it returns a 0. So scanf starts at the beginning and it says, okay, first I got to find an integer. And if it finds a j, it says, well, that's not part of an integer, it returns 0. And it gives up as soon as it fails to match something in this pattern.
So you want it to equal 1, not 2.
So you want it to equal exactly 1.
Shoot.
And that's the only way that we know that the input was correct. So we got to save this somewhere. So we can say integer return value equals. All right, and there's different ways we can do this. So we could say if return value is equal to 2, or is equal to 1, then they type in an integer with nothing else after it. Yeah.
Oh, wait, did you do the percent s afterwards to check to make sure there? Oh.
Make sure there's nothing else after the integer.
I answered the question as soon as I started talking.
Okay, cool. All right, so if return val is 1, we had good input, so we can just print out number times number. And I'm just going to say return after that because we're done. Yeah,
There's 2 curly braces after if. Is that
that's a problem.
okay?
Thanks. Was that your catch too? Okay. All right. Otherwise, something went wrong with the input. And print out error. And then we could return or just fall off the edge of the earth. All right. Or you could do it the other way. You could say if return val is not 1, print out error and return. Otherwise, print out num times num. Or I could not return here, and I could put this in an else block. And you know, as usual, there's different ways you can get to the same thing. All right. So problems with scanf syntax were fairly common occurrences. Using a single equal sign here instead of a double equal sign will compile, but will always tell you that you have a good value, because that'll assign ret val to 1, and then you're saying if 1, and 1 is considered true, so it'll go ahead and assume you didn't have an error. Not having a return here would print out your number, and then it would print out error, so things like that. Trying to print ampersand num is not what you want, right? Num's just an int, so you can print num times num. And nothing to do with argc, argv here. You could put them in main if you want, but you're not going to use them, right? Because first you're asking the user for something, and then getting the value from them. Does that make some sense? All right, so question 2, another C program. Here we're using command line arguments, so not prompting the user and using fgets, but we're just reading from the command line. So whatever you type in, name of the program, and then some word, and then some integer. All right, command line arguments, you got to have argc, argv. And if we set it up in the usual way, this will be argv0, this will be argv1, this will be argv2. And you cannot get away with doing something like this. And I saw a bunch of people trying to do this. They're trying to scan argv itself with a %s, %d, hoping to pick up the word and the number of times to print it. Okay, that's not how argv works. It makes sense, but that's just not how it works. If you had a string that contained, you know, this first and second command line argument next to each other with a space in between, this would be a perfectly great way to parse it. Okay, but that's not what argv is. Argv is not even a string, right? It's an array of strings.
It's an array of pointers.
It's an array of pointers. So if you try to scan that, you're going to get weird stuff, right? What you really want to do is you want to do something like Sscanf argv bracket 2 %d with a %s trick num extra. To take this argument, which is a string, right? Every argument is a string, and convert it into an integer by using Sscanf, and make sure this returns exactly 1. So we could do something like this. Alright, so this would take the argv bracket 2, which is the third command line argument, which should be the number of times you want to repeat the word, and it will try to convert it into an integer, and it will throw extra stuff into extra. And we can look at the return val. Okay, what's wrong with this line of code, though? Why would I take off points for this if this was how your program started?
We didn't even check if argv existed.
We don't know if argv exists. Right, so I do Q2 hello 5, that works fine. Oh, that's a bummer. There we go. If I just do Q2 in a word, I get a seg fault. So any time that you're going to try to use argv bracket 2, make sure that you know it's not going to seg fault. And how do you know that? You got to know that it was given a value, and you can tell that by looking at argc. So if you have 3 arguments here, argc will be equal to 3. If you just say program hello, argc will be equal to 2. If you just say program, argc will be equal to 1. If you say program hello 5 more stuff, argc will be equal to 4. If argc is 4, you're not going to seg fault because argc bracket 2 exists, but that's a misuse of your program because you had an extra argument over here that shouldn't be there. So if you look at the specification on this, it says if there are not exactly 2 arguments given, print error and exit. So exactly 2 arguments, program name, argument 1, argument 2, that's argc equals 3. So before we do any of this, let's check argc. So if argc is not 3, we'll print out error and we'll just return. That's too many arguments, that's not enough arguments. Once we get past that if statement, we know that we have exactly 3 arguments, so argv bracket 2 is something that we can feed to Sscanf. So now let's see if it's an integer. So we'll run it through Sscanf, we'll take the return value, and if return value is not equal to 1, guess what? It's another error and we just return. All right, now we had exactly 2 arguments, and the second argument is exactly an integer. What do? We just want to print out the word however many times that integer says. So a for loop will work, 0 to less than num, you just print out argv bracket 1. Now remember, argv is an array of strings, so argv bracket 1 is a string. It's as much a string as extra is a string. And it's not any string, it's exactly the string containing that first command line argument, which was the word we want to print out. So it's perfectly legal, and it's actually quite fine to use argv bracket 1 right here in this print statement. What you probably do not want to do is something like this. So use Sscanf with a %s to convert argv bracket 1 into a string called temp and then print out temp. Best case, this does no harm. Worst case, it actually truncates your string. If your string actually contains spaces, and I know I said it doesn't contain spaces, but if it did contain spaces, this would stop scanning at the first space and temp would just be the first piece of argv bracket 1. Also, if argv bracket 1 is really big, this could throw a seg fault. You could get a buffer overrun, which we could have done with our extra check too. But there's no benefit to doing this, right? Because argv bracket 1 is a string, and you can use it anywhere that you expect a string, including printf or Sscanf. So even though I always say Sscanf is like your friend and you should get to know it really well, you don't have to use it unless you're doing a conversion, right? Typically from something like a number, like an integer. All right, what else? Yeah, main thing, just make sure when you're checking to see if that argument is a number, use Sscanf, look at the return value. Once you've turned this thing into num, there's no way you can look at the value of num and tell if you have an integer or not. You can't say if it's equal to 0, because they might have said 0. You can't say if it's equal to itself times 1 like we do in bash, because it is an integer. And if you multiply by 1, it's not going to change its value. So you got to look at the return from Sscanf to be able to tell. All right, other questions on that? All right, so questions 3 and 4 were bash scripts, not C programs. Question 3, read 3 numbers, print them out in increasing order. And I saw a lot of solutions to this. Some of which, no, they were actually really good. I was trying to think how best to phrase that. There were a number of creative solutions that worked perfectly, right? Which is cool to see. I had 1 or 2 solutions in mind that was basically involved a bunch of if statements, and a lot of people did those. So logistical issues, right? You can't say something like read $1, right? $1 is a variable that has a value if we're running a script. But if I say read $1, what's going to happen? It's going to look at the value of this variable $1. It's going to replace $1 with that value. And I'm going to read into some variable with some weird name, right? In this case, $1 doesn't have a value. And so if I say read $1 and I say hello, and I try to echo $1, it's not equal to hello. Why? Because I didn't say read into a variable named 1. I said read into the value of $1, which is just a space. So my read statement basically just said read, and I didn't tell it to store that result anywhere. So that value is lost. If I say read $0, I actually get an error, because guess what? $0 has a value, which is the name of my current program, which is bash. And so read $0 translates into read/bin/bash. Okay, and similarly, if you say something like read $A, that's not going to read into the value A. Because if A equals haha and I say read $A and I say hello, that doesn't change the value of A, it changes the value of haha. So dollar signs are when you want to expand the value of a variable. If you want to read into a variable, read name of variable, no $. All that explanation, I think it only cost you a point. But dollar signs expand the value of a variable. So so first of all, ask the user to enter 3 numbers. Do your prompt, okay? And then do your input. Read A, read B, read C, or whatever you called your variables. And there's no parsing to do in bash, because we can just treat these things like integers. We can throw them in if statements, we can throw them in $paren, and so on and so forth. All right, so pretty much everybody nailed the syntax perfectly, which is great. So square brackets, 2 of them, around your conditions for ifs and so on and so forth, people got that. ELIF for else if, people got that. Phi at the end of ifs, people got that. While loops on question 4, do, done, perfect. So very happy with that. Using -LE for less than or equal instead of less than sign equals sign. So that's fantastic. So the other piece of this was the algorithm, right? How do you print out your numbers in increasing order? So here's one way that I had in mind, and I'll just do this in pseudocode because I don't want to write square brackets and -LT. If A is less than B and B is less than C, sorry, if A is less than B and A is less than C, then we know A is the smallest number, right? So we're going to say print A. And then we've got to print either B, C, or CB. Whichever one is smaller, we want to print first. So if B is less than if B is less than C, print B and C, else print C and B. So that's one case where A was the smallest number. We have a second case which is parallel. If B is less than A and B is less than C, then we print B first. And then we print either AC or CA. And then our third case is where C is less than A and C is less than B. And we print C, and then we print either AB or BA. So that's 3 compound if statements, each with a print and an if else inside, that would get you the numbers in increasing order. Another option is to do 6 if statements. So we can do something like, if A is less than B and B is less than C, then print ABC, because that's the order. If A is less than C and C is less than B, then print ACB. And you got 6 possible orders, so you do these 6 if statements and you're done. So that's another way to do it. Some people started off as if A is less than B and A is less than C, then minimum equals A. Other 1 equals B, other 2 equals C. And then if B is less than A and C, minimum equals B, and other 1 equals A, and other 2 equals C. And so they marched through 3 statements and they found the minimum variable, and then they had 2 other variables that held the other 2 values in them. And then they just did one comparison on those and printed them out in the right order. Some people did like a piece of a bubble sort where they marched through, and if A and B were out of order, they swapped. If B and C were out of order, they swapped. If A and C were out, they swapped. And they looped until everything was in order, and then they printed out. That was cool. So there's a variety of approaches. Yeah,
Doesn't bubble sort use arrays?
doesn't have to. I mean, the algorithm is really just sort of go through and compare things that are next to each other. If in your mind you've got A, B, C as your three variables, you can think of them as an array. Yeah, but you can still kind of do the spirit of a bubble sort. Only because we know how many things we're dealing with. All right, so I did not take off for some things. For example, all this code I wrote will not work if we have numbers that are equal. For example, if A and B were equal to each other, none of these if statements would fire, right? So you really want like soft inequalities on here. And it doesn't matter inside here because BC and CB would be the same if they're equal. But you need to make sure about things like that. I did not take off for that. I did not get into the minutia of your algorithms, okay, for the most part. So if it looked like you were doing the right thing and it looked like you had most of the cases covered, you got full credit for that. If it looked like half the cases were missing, I took off some points for that. If it looked like you were kind of thinking about a useful algorithm that might get you there, but there were some details that still needed to be worked out, I took off a few points for that. But by and large, if it looked like you were doing the right thing, right, you got most of the credit. So the mistakes tended to be things like printing out in decreasing order instead of increasing order. Number of people printed largest to smallest instead of smallest to largest. And you know, I might not take off for that normally, except it could be that you just didn't read the instructions carefully enough, or it could be that you made some fundamental logic error and you were trying to do smallest to largest and it's coming out backwards. So that was a few points. But by and large, looked like people were on the right track on this. And like I say, a number of solutions that looked like they would work perfectly. All right, and then question 4, no input, no parsing. This is just a program. You run it, it always does the same thing. It prints 101 lines of output. So a header and then just a table of numbers, squares, and cubes. I have a book in my office of this, by the way, if you ever get curious. Before computers, you used to buy books of calculations. And there's a section in the book that just has squares and cubes of numbers. And it's just all these numbers on the left and then the square and the cube next to them. And that's how people did calculation. They looked up these things in books. Because why not? I even had one as a kid. It was a book of random numbers.
Did it change every time you opened it up?
No, but you know, but it had an, you know, sometimes they have a little page in the front for like errata where there's like mistakes. It had one of those. Like, oh yeah, this should have been a 2 instead of a 4 over here. Got to get the right random number. So let's write this Q4.
That's a dumb joke. It is. It was fun.
So all right, so bin bash. So print out the header. Almost nobody printed the header, so I didn't take off for that. But the header, kind of nice. All right, so there's the header. So we want to print out 100 lines of output now. So we're going to do a while loop, and I said in the beginning of the test, and I wrote on the board, you got to use a while loop. So for loop doesn't work here for credit. So we need a value for n. I'm just going to start n at 1. And then I'm going to do a while loop. So since I'm starting at 1, I'm going to make my while loop while n is less than or equal to 100. Something like that would work. And if you didn't put spaces in the output, I didn't take off points for that. Yeah.
Doesn't your, doesn't it need to iterate? The
Oh, yes.
N1.
I just lost 2 points.
Can I get minor back?
Yeah, right. So make sure you increment n. Thank you. All right, so this would work fine. We could also have just done. We could also have just done that.
You need a $sign up on the first time.
Actually, you don't. I don't think.
Do you need a quotation?
Let's find out. I do need a quotation.
Oh, no, I see. The parentheses are just weird.
Yeah. Okay, that works. Yeah, that's better.
And you're missing a paren.
I am missing a close paren. Oh man, I'm failing my exam. All right. So that should. All right, so there's your table.
Wow, I'm so impressed with
Well, I had the whole class helping me. So it's easy. All right, so this one I did take off if you were off by 1. So if you started n at 0 and wrote it like this would also print a line for 0. 0 squared, 0 cubed. If you did less than 100, it would skip 100. So I paid attention to that. But other than that, most people either got this or a bunch of people left this blank, probably because it was the 4th problem, and I think people ran out of time. But you needed some kind of while loop that iterates 100 times and just prints out these values. Let me go really quickly through question 5, or part B. So make a directory named work, so make dir work. Spelled correctly. So now I have a directory named work underneath here. And one named whirl. Show your current working directory, that's pwd, print working directory. Change your directory to the directory named work, so change directory to work. So now if I did pwd, I'm under mt/work. List the files in your present directory, so that's just ls, and I don't have any files in here. Edit a file named main.c, so vi main.c or nano main.c. So now I've got a main.c.
I was thinking about that during the exam. Like, what if I did div.main.c?
Yeah. Compile main.c to create an executable gcc-o program main.c. And I don't actually have a program, but or gcc main.c-o program would work also. Execute the program named program, that's just program, or /program, except I don't have one because it didn't compile. Delete the program, remove program. Rename main.c to program.c, that's move main.c program.c. If you copy and then delete main, that's not technically a rename. It's creating a new file, separate location on disk, separate permissions, all that kind of stuff. So MV is a rename, CP is a copy. So copy program.c
Isn't there an
program.save.
actual rename? It's like REN or something?
It's not RN because a bunch of people did that.
REN.
Might be. There are 18 similar ones. All right, delete, rename, copy, make a new directory named backup, so make dir backup, and then copy program.save to backup. It could be backup, it could be backup slash, it cannot be slash backup because that would put it under the root directories, subdir named backup. All right, and then git, people pretty much got these down. Git init to initialize, git add program.c, git commit to commit program.c. And then 2 commands to create the GitLab repo and copy. Git remote add origin, git at gitlab.com, username / midterm.git. And if you missed the syntax of that, it's okay. You usually just up arrow it or it's written down somewhere, but that would be the command for it. And then git push origin master to copy over. And then a new file, git add, git commit. And then to push it, it's just git push origin master. All right, so talk to me if you want to talk about comments or go over your exam. Remember, there's no class tomorrow, so I'll see you on Wednesday.
For why?
For why?
Because it's taking the entire day to play Minecraft.
Doing sabbatical.